Okay, let's go. Vamos. So this lesson is properties of exponents, but this is like the break between linear things and nonlinear things, right? Everything we've done up to now has been linear. So now we need to do things that have exponents. You know, if things go the way that I expect, we'll be taking a quiz on the 1st, which is next Tuesday, and our test will be on the 7th. Yeah. Yoo-hoo. 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 Okay. So, quiet, please. Let's go. We got a lot of slides to go through. Put it away. So again, we're making the change from linear, which means graphs are straight lines, which means variable terms are always have the variable raised to the first power, to nonlinear, which means obviously the graphs will not be straight lines. You know, they'll have terms like x squared or x to the third, which means it's going to be a curve in the graph. Or it could be a square root or a cubed root, which we'll learn eventually. That's like saying the cubed root of x is like saying x to the 1/3. The square root of x is like saying x to the 1/2. That's why I say this thing. Sometimes you could have exponents that are fractions. So linear to nonlinear. They not straight lines? You know, the y will come out when we get to each one of those in turn, because usually when you get to a new kind of a function, you really don't know what it's going to do until you plot some points and just see what kind of shape comes out, all right? It's just the nature of the relationships. You know, if I have y equals x squared, right, when I plug in x equals 1, I get y equals 1. When I do x equals 2, I get 4. When I do x equals 3, I get 9. Those 3 points aren't going to be connected by a straight line. They're going to have somewhat of a curve to them, you know. But until we see it, I mean, it's still kind of like all about, you know, the guy who first came up with, let's have a coordinate axis. Let's have x be the change in the horizontal. Let's let y be the change in the vertical, and assign every point in the plane an address. And then we have functions like this. Before that, they didn't really have that kind of concept at all. Now, this is actually pretty close to a slide we saw on, I think, day 1 in this class, which is something that shows these 3 vocabulary words and what we mean by them, right? 4 squared equals 16 is the way you would say that, right? The base is 4. We definitely are going to refer to the base. When we're raising something to an exponent, or has an exponent or raised to a power, whichever you want to say, the base is the thing that's being raised to it, right? The exponent is just that number, right? The whole thing, 4 squared, is what the book is calling the power. The reality is that we're going to use exponent and power kind of interchangeably. You know, we'll say, you know, raised to the power of 2. Okay, well, maybe we should have said raised to an exponent of 2, you know, if we were really being technically correct. But I think people use those two just pretty much interchangeably. We're not really so concerned about the words. Right, so power and exponent, pretty much the same thing. The base is definitely the number that's being raised to the power or to the exponent. So we're going to spend 2 days going through the powers of exponents. I believe you copied 6 of them, right? 6 of them. I'm trying to remember if there's like 2. One of them contained 2, maybe. So let's remind what it is to raise to a power. What does it mean when we raise to a power, right? If I say x squared, that means x times x. right? It's multiply that thing, the base, times itself 2 times. X to the third would be x times x times x. Multiply the base times itself 3 times. Okay. Right. Not to be confused with x plus x plus x. That's 3x. Right. So when I say x to the third, that's not the same thing as 3x. Right. That's x plus x plus x. Right. That's combining like terms. 1 plus 1 plus 1. That's 3x. So properties of exponents are something that you'll use from now on, but it's not really covered again. Usually in Algebra 2 we review it. Maybe it's a day, maybe it's part of the day, but it's just referring to these couple days that we have right now. I think they'll go fast. You ready? So this was the first property. You already copied it. You shouldn't have to spend the whole, 5 minutes copying this because you did this. But I'm just trying to talk about it, right? So if I multiply the same base, like x, raised to 2 different powers, x squared times x to the third. Again, I know that x squared means x times x, and x to the third means x times x times x, which means I am multiplying x together how many times? All in a row? 5 times, right? So that is x to the fifth. So it's I took these exponents, 2 plus 3, and I got 5. And you think you can see why that works that way. Because in the end, we're just saying whatever is the exponent, that's how many x's you get out of that one. Whatever is the exponent, that's how many you get in there. When you write them all in a row, you're just adding it up. So this is the property that you copied. A to the m times a to the n, which is important that it's a. It's got to be the same thing. It can't be a to the m and b to the n. That wouldn't work. But the same base raised to different powers, add the exponents. And this was the example that was given in what you copied, right? Add the exponents. 6 plus 3 equals 9. So multiply the same base raised to different powers by adding the exponents. So what would this one be? 7 to the third times 7 to the fifth. Trinity, do you need a calculator? All right, that's 7 to the 3 plus 5, which is 7 to the 8. Okay. How about this one? How many 9s is that? Okay. So what about the first one? If you don't see an exponent, that means it's a 1, right? It's there once, but we don't have to put a 1 there. We know that. So, but when you're adding up the exponents, you got to include that 1. So this is going to be 9 to the 1 plus 8 plus 2, which is 9 to the 11th. So here's your you try. I'm not even going to pause the video because it shouldn't take you that long, right? How many 5s is that? 5 to the 10th. How many x's is that? X to the 9th. Is everybody okay with that? No issues? Okay, here's the next property, right? If you have something that's being raised to a power, and then you have another power outside the parentheses, Like x squared squared means, again, what does it mean to square something? It means multiply that thing times itself. So that's x squared times x squared. But now we're using the first property, right? Since I'm multiplying the same base raised to different exponents, I add the exponents and I get 2 plus 2 is 4, right? That's not a great example because actually 2 times 2 would have been 4 too. But how about this one? X squared to the third power would be x squared times x squared times x squared, right? 3 times multiply x squared times itself. And now, how many x's is that? 2 plus 2 plus 2 is 6. So what's going on, right? 2 times 2 is 4. 2 times 3 is 6. The property then is, if you have a to the m in parentheses raised to another power, which is n, you multiply. Right? And this was the example that you copied, right? 3 to the 4th squared is 3 to the 4 times 2, which is 3 to the 8. So when you raise a power to a power, multiply. Okay, is that the first one? No. Okay, so how many negative 6s should I have? Negative 6 squared to the 5th. What do I do with these two powers? Multiply. So that's negative 6 to the 2 times 5, which is negative 6 to the 10th. Right? Multiply. Right? How many y plus 2's are there? When you raise a power to a power, what do you do? Yeah, so again, that's going to be a multiply. So that's y plus 2 to the 12th. Good, agree, Sarah? So try those two. Again, I'm not even going to pause because it shouldn't take too long. All right, how many n's are there? 3 times 6 equals 18. How many m plus 1's are there? M plus 1 to the 5 times 4, which is 20. Right? Two properties done. No, some of them next time. Okay, if you have more than one factor, right, which is inside parentheses, and then there's a power outside the parentheses, like this, x, y to the 4th. Well, what does it mean to say raise something to the 4th power? Times itself 4 times, right? So that would be xy times xy times xy times xy. And now I do a little associative property, like move the x's and the y's so that they're together. And it's actually, there were 4 x's there and there were 4 y's. So it's actually x to the 4th, y to the 4th. So what you can see is that exponent of 4, you could have moved inside on the x and on the y. And you can even think of it, because most people will say that this way, they'll say distribute. I mean, it's not really distributive property, because distributive is when you have multiplying outside parentheses and we know what that is. But if you want to think of it like distribute, that's fine too. So the property is this, right? And this could be with more than just two factors inside parentheses, right? But if you have parentheses and then raised to a power, then you can bring that exponent in on all the factors that are in there. Right? This was the example that you had in the what you copied, right? 23 times 17 to the fifth would be 23 to the fifth, 17 to the fifth. Now, you might, we make a lot of mistakes with this, not just you guys. Math students make mistakes with this all the time. Like here, right, does that mean that I can say m to the 20th and 1 to the 20th? And the answer is no, right? Because these two are not multiplying times each other. They're being added together, right? So this does not work unless these are multiplied together, right? They come in on factors. So again, you can think of it as distributing, and caution, it's not the same thing as the power of a sum, right? That you can't do. The typical example of that is something like this. If I said, what is x plus 2 squared? And a lot of students will say x squared plus 4. But that's not right. That's like you're using this property like it did work that way, but it doesn't work that way, right? X plus 2 squared means x plus 2 times x plus 2. It means that thing times itself twice. But this happens so often that I read a book, it was written in 1988 by this professor who was so frustrated by the whole thing. He said something like, if I had a nickel for every time I'd seen that mistake, I'd be rich by now. But we still make it all the time. Okay. So let me get to the next. Okay, so how would we simplify that one? Using this property. Right? You can distribute it to both. 24 to the 8th times 13 to the 8th. Now, at this point, we're not interested in doing more than that. Obviously, you could put in the calculator 24 to the 8th and see what the number is, but we're not trying to do that. We're just trying to show how this property works. How about this one? So again, you got to distribute the 2 to everything that's inside, right? So that becomes 9 squared, x squared, y squared. And even though what I just said, I said, we don't simplify this, sometimes when they have something like 9 squared, you're definitely going to see them write it like 81. It's not consistent. Good stuff. Okay, how about these two? Is that supposed to be a U-chart? No, this is not supposed to be a U-chart. What do you think the first one would equal? Okay, and what is negative 4 squared equal? Simplify the negative 4 squared. Okay, here's the thing between the two, right? This one is positive 16z squared because the negative is inside. So that means that it's being squared just like the 4 and the z. This one, the negative is outside, so it's not part of what's being squared. So this is negative 16z squared. So be careful, if a minus is being affected by the exponent or not. It's a common mistake. Clean this up a little bit. Okay. So try those two. So what's the first one? (42 squared, 12 squared). Stop. How about the second one? Positive 9n squared. So when we took that in, right, we got, that's like -3 squared. And when you square a negative, what do you get? Positive. Did anybody put it in their calculator and do -3 squared? I don't think most people took calculators today, did you? I mean, this is one of the things, like, in your mind, you know that -3 squared is positive 9, right? But if you have the calculator in front of you and you do, I'll bring it up, clear. So if I just put in the calculator, watch this, -3 squared, I get -9. Why? Yeah. Yeah, it's not squaring the negative. If you wanted to square the negative, you got to put -3 in parentheses. So don't let the calculator have you say that -3 squared is a negative number. You know better than that, right? But we make that mistake quite a bit. So it must be a new property. Okay, so this is like a combination. There's a little bit more to do. Okay, so simplify. First, let's use the power of a power property, right? That would be 2 squared times x to the third squared. And we still have an x to the fourth. Actually, that was a distribute outside parentheses. Now, here's the power, raising a power to a power. What does that simplify as? X to the third squared is x to the sixth. You multiply, right? And now what is x to the sixth times x to the fourth? What do you do with the exponents? You add them, right? And while I'm at it, I'm just going to say 2 squared is 4. Okay. So you could get like more than one property in the same problem that you got to deal with. So here's the next property. We're up to number 20, right? So it's going fast. So if you divide the same base with different exponents, right? If this is x to the fifth over x squared, if I just write out the x's, that makes 5 x's in the numerator and 2 in the denominator. And remember, when you have a common factor in the numerator and denominator, they cancel, right? So if I cancel 2 of them, what's left? X times x times x, x to the third, right? So x to the fifth over x squared is x to the third. So what does it look like you did with the 5 and the 2? You subtracted, and that's the property, right? A to the m divided by a to the m is a to the m minus n. Subtract. All right, and this was the example that you had that you copied already. 4 to the 7th over 4 squared is 4 to the 7 minus 2, which is 4 to the 5th. Okay, what is this? 8 to the 10th divided by 8 to the 4th. Subtract, right? So it's 8 to the 10 minus 4, which is 8 to the 6th. All right, how about that one? Looks like there's more than one thing to do here, right? How do you simplify the numerator? 5 to the 4th times 5 to the 8th. Add the exponents, right? So that's 5 to the 12th. And you still got to divide by 5 to the 7th. So then you subtract, right? That's 5 to the 5th. I mean, do you really need to like do it in two different steps? Not really. I mean, you could tell that things in the numerator will subtract things in the denominator. 4 plus 8 minus 7 is 5. So try these two. How many sixes? Right. 11 minus 5 is 6. How many nines? 4 plus 3 minus 2, 5. Okay, now we have another property of, here's some parentheses with an exponent outside, but this time what's inside is a quotient. Before it was a product, a, b to the m. You know, now it's a divided by b to the m, but it works the same, right? You can bring you can bring that exponent inside. You can think of it like distributing it, right? Distribute it to the a and the b, right? This was the example you had that you already copied. 3 halves to the 7th is 3 to the 7th over 2 to the 7th. So what would this one be? X over y to the third. Yep, x to the third over y to the third. Simple. Okay, and how about this one? What's going to happen to the negative? You square a negative, you get a positive. So actually that's going to go away. 7 squared over x squared. Positive, right? That's a plus. And 7 squared is not 14. Okay. Trinity, Trinity, Trinity. Remember when you got everything right and you were so happy about everything we did? Okay, do that one. See, it's only 8:34. We're on the second to the last slide before we just go objectives and homework. Isn't that amazing? Okay, quiet please, not quite done, right? So you got to distribute that 2 onto all these 3 factors. So it's x squared squared, and 4 squared, and y squared. And what do you do to these 2? When you raise a power to a power, you multiply. No, you multiply, it happens to be the same, but okay, 6, and then 4 squared is 16. So what was my last slide? I forget. How about this one? This one we do together. It doesn't say you try. So what should I write down here? Four to the... Okay, next. X squared to the third. Then what? 5 to the third. And y to the third. Okay. What's 4 to the third? 4 times 4 times 4. 64. What's x squared to the third? X squared to the third. X to the sixth. Okay. What's 5 to the third? That's 5 times 3. 125. And y to the third. That's the answer. It's a lot of homework.